Kumar. Welcome back to my channel. Today we are diving into one of the most fundamental concept in software development, that is design patterns. If we are building an application that you want to maintain, scale and work on with a team, this video is for you. Let's get started. First, let's understand why patterns matters. Without them, here what happens means we will find ourselves writing repetitive code across multiple projects. We solve the same problems in inconsistent ways, and also we can. It is difficult to maintain and modify. The team members cannot understand each other code. For example, I write a code and my teammate wrote another code. We cannot understand the same code. The code which we have written by the other team member. Uh, so, what exactly are design patterns? Think of them as proven reusable blueprints for solving recurring design problems. They are timely tested solutions documented by experienced developers over decades. Mainly, the benefits are uh, the common language across teams and projects, and reduce errors and design complexities. Battle tested in real world applications. And design patterns are organized into three main categories: creational patterns, structural patterns, behavioral patterns. Creational patterns focuses on how to create objects efficiently, and structural patterns focuses on how to organize the and compose the objects. Behavioral patterns focuses on how objects communicate and interact with each other. Over the next few minutes, I will show you the examples for each category with real use cases. Okay, so the first one is creational patterns, right? That is Singleton. Okay, let's start with Singleton, a creational pattern. We need exactly one object globally. Let's imagine that, like a database connection or logger. Okay, multiple instances are there, would cause conflicts for this problem. So in Singleton, it ensures only one instance existence and controlled global access point. And thread safe is production in production environments. And real time example is the connectivity in Java. We connect JDBC in Java, right? So it is the best example for creational patterns. And the second one is creational factory. Okay, in this creational factory pattern, we need to create different objects types based on conditions, but you don't want to scatter creation logic throughout your code. Factory patterns provides decoupled object creation, and also need new types without modifying the existing code. Centralized creation of logic is very important. Uh, think of it like an assembly line where you request an object type and the factory builds it for you. The third one is structural adapter. Uh, let's look at adapter, a structural pattern. If we have two incompatible interfaces that need to work together, like integrating legacy code with a new system, then the adapter acts as a translator between these two. So it converts one interface to another and allows compatible objects to collaborate. Perfect for integrating old and new systems. Like we use USBs, right? So it is the best example for this, and they convert different socket types to the devices and can communicate with each other. Next, structural decorators. The structural decorators solves different problems. For example, we want to add features to the class without modifying it directly. So inheritance gets messy fast. So decorator wraps objects with additional behaviors. It adds some features dynamically at runtime, and flexible alternate to inheritance compose multiple features together. So let's think of decorating a coffee. Start with black coffee, then add cream, sugar. Each decorator adds a behavior, right? So the same thing will be done here. And let's jump to behavioral patterns, the that observes pattern in fundamental. When one object changes, many other need to know immediately, but we don't want tight coupling. Okay, so observer pattern provides loose coupling between objects and notification system for changes. One publisher, multiple subscribers will be there, and event listeners in JavaScript. Notification systems is in mobile applications. So in mobile applications, we use JavaScript for notification systems. So it is the real world example for behavioral observer. And behavioral strategy, finally the strategy pattern is we have multiple ways to solve the same problem: sorting algorithms, payment methods, etc. And you want to switch between them a runtime. Then strategy encapsulates algorithms. Each algorithm is a separate class, and it is chosen which one to use at real time. Easy to add new strategies later. Common misconceptions here. There is a critical myth that patterns allows improve code. It is true, but solving a specific problems, it's not impossible, so it is unnecessary for complexity. Okay, when to use design patterns, actually it is the doubt to how where we can use these patterns and when we have to use these patterns. So when should we actually use patterns means the problem appears across multiple projects. It reduces code duplication, it improves team communication, feature changes, etc. So when we have multiple projects, we can use these design patterns. And how to use? So by identifying a pattern or a recursive code problem and researching about the pattern and evaluate it, then we can apply this context in our real time problem. What are the real time examples, do you know? The real time examples are database connections, like Singleton, which we have discussed in the previous slide. So next, observer. So observer means nothing but notification system we discussed in the previous slide. And strategy, different payment methods in e-commerce websites, and also sorting techniques like that. And implementing a pattern. When you implement a pattern, we have to follow some rules, that is write an interface on or abstract class that defines the pattern structure, and create uh, concert implementation of each variant. Replace hard coded logic with pattern based cells. Test thoroughly before production. These are the most important steps to follow. And anti patterns, why patterns matter means anti patterns means, for example, god objects, one class doing everything. or no structure, everything tagged, and copy paste duplication instead of patterns. uh, Patterns matter because they give you reusability, maintainability, and team communication. So patterns are solution to recurring problems, and also the three categories which we have discussed till now, uh, that are the key points. And study one pattern deeply, that is, it may be singleton or another patterns, we have to study completely and we have to implement in our current project by reviewing or reviewing the code, experienced developers, and practice it in many projects. So this will help you more. And design pattern elements, reusable object oriented software, and also refactoring guru, source making design patterns. These are the resources which you can help uh, you. And this is about design patterns. If you have any questions, you can comment it, I will try to solve them. Thank you.